Okay, everyone, let's get started. I'm going to go ahead and hide my camera because you don't need to see it. Plus, I'm going to be swapping between different screens. So it's going to get weird with the camera. So I'm turning it off, and we'll just start coding. But first, we're going to talk about using variables and constants, and I'll show that in code as well. So first off, you need to know what constants and variables and literal constants are, what a numerical constant is, what a named constant is, and just so you all know, a constant is a specific piece of code or a specific variable that cannot be changed while the program is running. So if you make a constant and you try to change it, it will error out. A literal constant means the value is taken literally at each use. So like a string literal or a number, that particular thing is a literal constant. A number is technically a numeric constant, but a literal constant is like just a string. A numeric constant is like a 5 or a 4 or whatever. An unnamed constant is when no identifier is associated with a constant. All right. A variable is a named memory location that is used to store a value. It can only hold one value at a time, and its value can change. Data types are what kind of data is being stored. Now, we use data types to identify how much memory we're going to allocate to it, or what type of operations can be performed on the data. There are two different kinds of data types that we are concerned about in Java land. One is a primitive type. It's a simple data type. You store the actual value in memory. So if like a 2 is a 2, a car is technically a numeric value, but that is an A and a B and a C. You store a float as a float in memory, or double as a double in memory. It occupies a fixed amount of memory. A reference type points to a reference to the location instead of the actual location. And let me jump into some code in a little bit and show you each one of these and what they do. But first, let's just look at these primitive types. The first primitive type is byte. A byte is a byte length integer, which means its positive value could be up to 127, and its negative value is negative 128. It has 256 possible values because it holds a byte. A byte is 8 bits, so we can factor out. In fact, I will see if I can do this here, but we can factor out exactly how many locations or how much space can be held by a byte by simply taking the number of bits. And in this case, we have exactly, that didn't work. We have exactly, am I going to change this to scientific notation? Maybe I am. Let's see, make you scientific. There we go. So make 2, and I put this to the power of 8, which is the number of bits in a byte. I get 256. 0 holds a location as well. So we have 256 possible locations or values that a byte can represent, starting at 0, going to 255. Now we cut that in half. Negative numbers is 128, and then non-negative numbers is 128. And so what it does is it goes to 127 and negative 128. We're going to talk more about these primitive types and how much space they can hold later, but just be aware that a byte is 8 bits. A bit holds 2 specific choices, 1 and 0. A byte holds 256 possible values. A short holds more than that. An integer holds even more than that. A long integer holds more than an integer. Floats and doubles have actual decimal places. A double has twice the number of exponential value as a float. And a char is a single character. A Boolean value is true or false. Now let's step into some code and kind of look at how this works. Let me find my code, and we will swap over there. There we go. All right. Now I'm going to code. I'll call this datatypes.java. And there's my data types class. I'm going to call this public class data types. And I'm going to say public static void main string args. And I am going to start making some data. So I'm going to type in int a equals 5, right, double b, we'll say double b, and c equals 5.2. I'm going to make this a little larger because I think it's hard to see. I don't feel like that might increase much, but at least you can see it a little bit more. I'm going to shrink down my terminal. So here we have integer equals 5 and double b, it's equals 5.2. If I do Boolean, I'm going to just say Boolean b equals true. Alright, so Booleans can have two values, right? Alright, let me jump in here. I'm going to first of all save this file. This is data types file. I'm going to just hit Control S. It should save it over here. You see data types. I can come down here now and compile that as datatypes.java. Right, and I can run that. Okay, now what I want you to notice, Boolean B, Boolean G. There we go. That'll fix that problem. Control S that guy again, resaved. I'm going to recompile this, and there you go. All right, now I can run this program, and really nothing's going to happen if I run this because I don't have any output to the console. But there it is. All right. So what I want to do now is I want to say A is equal to C, right? And let me go ahead and print out values for A. I'll just let you guys know right now up front that this is this \t is a tab, right? So it gives us a certain number of spaces between. Because I kind of mix things and put things in a column order. We'll talk about that, these escape sequences later. But we'll do C and \t C plus C, and then we finally have a G. So we're going to use this line of code later on as well, but just know that it exists, and we're going to \t that guy as well. So I'm going to go ahead and run this now. I need to put a semicolon on that line, of course. Control save this, and I'm going to compile. Hopefully I did this without errors. When there's a lot of pluses, I tend to forget pluses and stuff, but we'll see how I did this time. And it looks like I did something wrong. A semicolon is expected. So that is because I forgot a plus right here. And yeah, in the future I'll show you guys a different way of concatenation that may run a little faster. But yeah, let's go ahead and run this. First I'll save it. Then we're going to compile it. And it gave me this error, lossy conversion from double to int. I cannot convert a double to int because I'm going to lose something. I'm going to lose that double, that particular decimal. But I can convert if I make this B is equal to A. I can convert the value. So we're gonna show this by copying this line of code down again, and I'm gonna go ahead and save that and run this, and what you'll notice is variable B might not have been initialized. Yes, it is. It's initialized right there. I see what it's saying. We're just going to say it equals 0 for now because it's initialized by declaring it a value. Okay, so Control S that, and what I can do now is compile this and run it, and you can see that I can assign B was 0, we passed in a 5, and it works, right? And of course G is true. But you can see now how I can pass an int to a double because it's like a larger, it has more precision, but I can't pass a double back to an int. Finally, I want to show you guys one other thing. So instead of making B just a value, we're going to make b a final, right? What I want you to see is when I make it a final, so this makes it a constant variable, it will always be 0. I'm going to go ahead and try to compile this. And it says, cannot assign a value to final variable b. What it's telling me is you cannot assign a value to a constant. That's not allowed. So make sure that you know that. Once you assign a value to a constant, it's not going to let you reassign that value. All right, we're going to stop there for now and get to the next lesson.